These two models can also be related to each other in the common factor model. According to Five and 1998, however, the spatial lag and spatial error models can only be combined for estimation if the neighborhood specifications, here, the W matrices of the lag and error components, differ. The spatial lag model is clearly related to a distributed lag interpretation, in that the lag-dependent variable, y, can be seen as equivalent to the sum of a power series of lagged independent variables stepping out across the map, with the impact of spillovers declining with successively higher powers of ρ, Five and 1998. Conversely, the spatial error model is a special case of a regression with a non-spherical error term, in which the off-diagonal elements of the covariance matrix express the structure of spatial dependence, Baltaki, 2003. Spatial lag and spatial error dependence tests allowed determining which of the two models was more suitable to the data. Subsequently, spatial regression models were created for each spatial regime. Measurements of log likelihood fit, aquatic information criteria, AIC, and Schwartz criteria, SC, for both models, OLS and spatial models, to verify if the inclusion of spatial parameters improve the regression model. The Schwartz criterion addresses the problem of selecting one of a number of models of different dimensions, Bailey and Gatrell, 1995. However, some authors, Burrow and McDonnell, 1998, Bailey and Gatrell, 1995, suggest the use of AIC to evaluate the best fit. The aquatic information criterion is expressed in equation 10, Pan, 2001. Where lic is the log of the maximized likelihood and k is the number of regression coefficients. A small AIC value suggests a high suitability of the tested model. Having selected the best model, the next step was to apply it to the Terra/Modis image to estimate the turbidity distribution. The resulting map was then used as a reference to evaluate the model. Random positions were selected on the image to run correlation analyses so as to assess the potential spatial model in the RSME. At each random geographical position, a 3x3 pixel window was averaged, obtaining both the measured and modeled value and computing the correlation.